Drying is a process to remove of water from wet substance to any unsaturated gas phase. There are two variables that we use in this experiment. That is, first, air temperature, and second is air velocity. These are the factors that affect the drying process. So for the application of the tray dryer, we use it in pharmaceutical industries and also food processing. And there are several types of dryers other than tray dryers, that is rotary dryer and also palm dryer. For this experiment, we use tray dryer, and also the method used is thermal method. Thermal method is a method where we use hot gas to remove the water from the substance. And also the process used is batch process. Batch process is basically a process where we put the sand in the tray into the equipment for the drying process.
Now I will talk about the theory behind the tray dryer. This equipment carries out drying process, which is a mass transfer process of liquid from wet solid to an unsaturated gas phase. In our experiment, we conducted the most common process, which is solid drying process. The rate of drying of wet solid in air changes throughout the drying period. This is because the controlling factors are different to each major section of drying rate curve. So, what is drying rate curve? Drying rate curve is a curve with free moisture content as the x-axis and drying rate as the y-axis. This drying rate curve is divided into three major sections, which are initial phase from A to B, constant rate phase from B to C, and lastly, the falling rate phase from C to E. So, at the initial phase, the evaporation rate will increase because sensible heat is continuously added to heat up the wet solid to the desired temperature for drying to take place. However, if the wet solid is hot initially, the drying rate will start at A prime. Now moving to the second phase, which is constant rate phase. Here the wet solids will exhibit a period where the drying rate is essentially constant, although the moisture content is reducing. This is because the large amount of water present on the wet solid maintains a saturated surface condition. This continuous film of water on the wet solids will keep the evaporation at a constant rate. Lastly, the falling rate phase happens when the surface of solid is no longer saturated with water. The rate of drying will decrease together with the moisture content. Starting from point C, the surface moisture has evaporated fully. Hence, the water will need to move through solid to the surface to be evaporated. The rate of drying now depends on the rate of moisture movement through the solid.
There are two main objectives in this experiment. The first one is to investigate the influence of the air temperature on the drying rate of wet solid at a constant velocity. The second objective in this experiment is to investigate the influence of air velocity on the drying rate of the wet solid at a constant humidity and temperature.
So this is the tray dryer. I'm going to explain to you briefly about the equipments or components are there in the tray dryer. So firstly, there's a fan where it draws all the air into the tray dryer, and secondly, there's the heat component inside where it can increase the temperature of the air where it can be controlled in this control panel. So these are the control panel. We can see here there's a fan control, heater control, heat and fan power, and as well as the display. And let's move on to the most important part, which is the drying section, where you can see here inside there's a tray, and the tray frame is connected to the digital balance, where this is to measure the weight of the materials on top of the tray. So for the first experiment, we're using dry sand, and this dry sand will be measured into the tray to get the weight, and then we'll get it out from the tray and we'll spray and we'll put it inside of the tray again to get the weight of the wet sand. Next, we'll move to this part where we turn on the fan and put the fan control into 0.1, and then we turn on the heater and put the heater control to 0.8. When the heater power became constant, we will get the readings of the wet bulb, the dry bulb and also the relative humidity. And lastly, we will record the weight of the sand, and this record will be taken in the interval of 5 minutes. And after the drying process is completed, we will continue this experiment and repeat it by changing the heater control from point A to point B.
In sub-experiment A, we investigate the influence of air temperature on the drying rate of a wet solid. To carry out this experiment, we need the air velocity and surrounding humidity content to be constant and the heater power to have a different air temperature. The air velocity was constant at 10.4 meters per second. The heater power was turned to point A, which is 33.1 watt. From the figure beside me, we observe that the drying rate took 75 minutes to complete the drying process. When the heater power was switched to point B, which is 50.1 watt, time taken for the wet sand to complete the drying process was 15 minutes, which is lesser than the point A heater power. This was because the temperature for heater power point B was higher than the heater power point A, and thus causing the air to have a higher temperature as the heat was provided much higher and can remove the water in the wet sand faster. For heater power point A, the drying rate was increased drastically to a maximum peak at time equal to 10 minutes. For heater power point B, the drying rate also increased to a maximum peak. The reason why the drying rate for heater power B was higher than the heater power A was the temperature of air provided by the heater B was higher than the heater A. Theoretically, the higher the temperature, the higher the drying rate. The higher temperature of the air can remove the water in the wet sand effectively. The theory was proved in this sub-experiment. After the drying rate reached a maximum peak, the drying rate will decrease gradually until the drying process was completed. This was because the less amount of water was stored in the wet sand for the evaporation process to occur, thus causing the drying rate to decrease. Based on the graph beside me, it can be divided into 3 main phases as stated by John Copeland in the theory, which are initial phase, constant rate drying phase, and lastly, falling rate period. The line AB was the initial phase, which means that the starting of the drying process that had the highest moisture on the surface of the wet sand. The water at the surface of the wet sand was evaporated to the surrounding continuously at a fast rate due to the high moisture content in the wet sand, while the surrounding air was unsaturated. That explains why the drying rate increased drastically while the moisture content decreased. Next, the graph will reach a point where the surface of the sand was fully unsaturated and the moisture content was very low. The point was the peak. Next, the drying process was then enter a constant rate period where the drying rate was constant, even the moisture content was decreasing. The temperature of the sand for both heater A and heater B was stable during this period. The moisture content at the end of this period was called critical moisture content. At this stage, the rate of the evaporation of water began to decrease with moisture content decrease. Lastly, the drying rate decreased when the moisture content of the wet solid decreased during the last stage, falling rate drying period. The water left in the wet sand was continually decreased until the whole sand was completely dry. Along the line D and E, the vaporized water moved through the core part of the sand into the surrounding air. So, lesser water was left in the wet sand and the drying rate was lower. The trend for line of heater B and heater A were the same. The heater B provides a high temperature for the air, thus causing a high drying rate than heater A. Theoretically, H2 will higher than H1. H1 was being measured at the area before reaching the tray of the sand. Thus, it will have a less moisture and lower relative humidity. However, in our experiment result, we got the opposite to the theory. This may be due to the faultiness of the equipment used.
In sub-experiment B, we investigated the effect of air velocity on the drying rate of a wet solid. The average velocity of fan 1 was 10.1 meter per second, while in fan 2 was 34.9 meter per second. So from the figure, we observed that the drying rate increases sharply at the beginning of drying process, reach maximum point, and continue to decrease with time until the drying process completed. The maximum drying rate of fan 2 is higher than fan 1. Theoretically, the higher the air velocity, the higher the drying rate, the shorter the time taken for complete drying. This is because higher air velocity can remove the water in the wet solid faster and easier. However, in our experiment, the time taken for fan 2 is longer than fan 1. The reason of this is because a higher air velocity will have higher relative humidity due to more water that was being evaporated to the surrounding air. When the humidity of surrounding air was higher, the diffusion of water from the solid to the solid surface will be harder. Hence, this results in a decreasing drying rate and a longer time for complete drying. Okay, so these figures on my left hand side shows the drying rate versus moisture content graph. The graph line can be divided into three main phases as stated in the theory, which are initial phase, constant rate phase, and falling rate phase. The explanation on the theory of the line graph is the same as in sub-experiment A. So from the figure, the drying rate increased until a maximum point and decreased gradually again with decreasing moisture content. Fan 2 provides a higher air velocity, thus causing higher drying rate than fan 1. However, the drying rate for fan 2 becomes lower after line AB. This was due to the high relative humidity that is carrying by the high velocity air. While conducting the experiment, we encountered a few errors which affected our result. Some modification and precautions should be made on the experiment so that a more accurate result can be obtained. So the first error is the systematic error of our tray dryer. This occurred in our electronic sensors and also digital balance, which were not calibrated properly to fit our experiment. To overcome this, proper checking and calibration should be made on the equipment of tray dryer so that they can function at an optimum level. The second error is the human error. This happens when we are collecting data for 5 minutes intervals. The reaction time might not be the same for every interval. So to overcome this, we must ensure the time taken is the same and be alert of the time interval.
In conclusion, there are two critical aspects in drying process. The first is heat transfer and the second one is mass transfer. Heat transfer is when liquid is being evaporated, while mass transfer is when the vapor is being transferred into the surrounding of gas. There are two parts of this experiment, which is the first part is when we use different air temperature with the same air velocity. The temperature is being controlled by heater A and heater B, where the heater B has a higher air temperature rather than heater A. Based on the graph of drying rate versus time, we can observe that when the air temperature increase, the drying rate increase and the total time of drying decrease. For the second part, we use different air velocity with the same temperature. The air velocity is being controlled by fan 1 and fan 2, where fan 2 has a higher air velocity rather than fan 1. It can be observed that when a higher air velocity, the drying rate will increase and the total time of drying will decrease. So as the drying process continues, a higher drying rate is achieved in the lower air velocity because of the effect of lower relative humidity and also wet bulb temperature. To conclude, throughout the experiment, the objectives of the experiment are achieved and also the theory of drying process is being proved by relevant evidence.
Thanks for watching. Don't forget to like and subscribe. I think our job is done now.
I'm Shaira. I'm Grace.
I'm Ridwan
I'm Dani.
and we're signing out.